All right, so let's talk about snapshot testing. So snapshot testing is a technique that is going to allow us to become independent of the browser. Right? So as we mentioned earlier, usually we have the browser parsing our JavaScript, parsing our HTML, parsing our React components, right, and then transforming that into a document object model that can then be rendered on the browser. So we're not going to have the browser, right? So we need to be able to generate these DOM representations, these DOM objects, but without the browser. And what we would like to be able to do is we need to be able to compare how is the DOM that we are generating compared to what we expect, the actual DOM that's being rendered. You know, I have these buttons over here and these headers over there and these lists and these tables and whatnot. Is it supposed to look like that? Right? Is the layout of the page what it's supposed to be? So we need to be able to have an objective way to measure this. Right? We need to say, well, somehow I need to be able to represent the actual page that I'm expecting compared to the actual page that it's actually being rendered, you know, and make a comparison between the two. So what snapshot testing allows us to do is, you know, as we manipulate the components, right, our test can generate snapshots, or DOM snapshots of each one of our modifications of our components, and you know, snapshots of the DOM that gets generated, the DOM that gets generated as we modify our DOM. And we need to be able to compare that. Now, these are the actual DOM objects that are being rendered every time we make a modification. We need to be able to compare them to see if that's the actual expected DOM object, right? That indeed the buttons are where they are and the tables where they are and whatnot, right? So we need to have a mechanism that looks at the rendering elements, render this element programmatically, not in the browser, and generate an initial file or initial representation of the DOM, and then use that as our base comparison. This is what we expect, and any modification that we make, right, are going to be compared against that base snapshot. So let's just to illustrate this concept. We're going to be using a tool called React Test Renderer. Right, this is going to be the mechanism, right? The tool that is going to be able to replace the browser, right, and generate the DOM for us, right, without needing the browser. Right? It's going to take a look at the input as the JavaScript input, our React input, our HTML that goes in there, the CSS, everything, right? Take it as an input, just like a browser does, right? A browser takes as input an HTML document, right? The JavaScript that goes along with it, any CSS style sheets, and then generates a DOM, and then it renders it for our frontal cortex, right? To parse. Here, we're not going to have the human user looking at anything. Instead, it's going to generate an object, right, and it's going to save it into a file. It's going to save the snapshot into a file. We're going to say that this is the expected value for our DOM object, and then any additional changes will be compared against this expected value. So here's a really trivial React component. It's a link. It's a hyperlink. It's very simple. We have an export default class, and it's MyLink, so it's just a hyperlink. But we're gonna also to illustrate the fact that we can replace a human being as the event generator. We'd like to be able to replace the user. We'll create a hyperlink that can respond to folks moving their mouse over the hyperlink and then taking the mouse away from the hyperlink. Right? And event handlers that are going to do small, tiny little changes to the DOM, right? And we need to be able to compare, right? Is this how it's supposed to behave, right? If I added a background color, or if I added, any particular class, or did I make any changes to the HTML elements, I need to be able to compare it. Is this what I was expecting? Okay. So this is my hyperlink. Here I have a constant status object that it's a map where we're going to have a couple of we're going to color the hyperlink either as normal if you haven't hovered over it, or we're gonna paint it as hovered if you put your mouse over the hyperlink. Okay. Anyway, so here we have a simple constructor, the super props, and the state. The state is going to maintain, what is the current status of the hyperlink? Are you putting your mouse over the hyperlink or not? Right. And we're gonna manipulate the state, based on whether you hover over the mouse or not. Okay. Okay. So we also have a couple of event handlers, on mouse enter, on mouse leave, that we're going to trigger, whenever we do move our mouse on top of the hyperlink, and when we move out the hyperlink, right? And so if we move the mouse over the hyperlink, we're going to call this function on mouse enter. And the only thing that's going to do is that it's going to update the state variable class. We're going to update it to status hover. And when we move the mouse away, when we leave the hyperlink, we're going to call this function. Right? And this function is going to update the state and toggle it back to normal. Right? So as you hover and remove, right, this is going to toggle between hover and normal. Hover, normal. Everybody okay? All right. Okay, so here's the hyperlink. When we render, here's the return. It returns a plain old hyperlink. That's all it returns, this hyperlink. And here are the two event handlers. So instead of we use on click quite a bit, or on change. Here's a two other event handlers: on mouse enter and on mouse leave. They're going to call the functions we just declared above. They're going to call those functions. So as we move up and down, we hover above and below, they're going to change that state. That's all they do. So that state, we're going to use that state to toggle the class name. So the DOM is going to change, right? We're going to have to render this hyperlink when the class name was at some point hover, yes, and when we moved away, right, this class name instead is going to be normal. So it's going to toggle between the two. We need to have both of them represented. We need to have an initial value for the hyperlink, for the page when it's rendered. Then we need a representation for one of the events, and then we need the representation for the other event. Yes? So we have three states. When it first loads, when we hover over it, and then when we leave. We're going to have three DOM elements, right? Three DOM representations for the same page, right? So the application can be in three different states. Okay, so having implemented that trivial React application, we need a test, right? And we're going to be using the technique, the snapshot technique, right? We want to be able to take snapshots of all these states, right? And we want to verify that if I make any change to my hyperlink or any logic to my event handlers, that somehow they're going to be compared against this initial state. If it's not behaving as expected, I want the test harness to let me know. You broke something, right? It was supposed to be hover, but it's no longer hover somehow, right? And that's the whole point of testing, right? That identifies these regressions. So here it is. So inside of a file that has an identical name to my component, but it has the .test in it. Okay. We load the React just like we normally would. We load the link that is under test, the component that is under test. We want to test that link, see if it's behaving correctly. We load the new tool here that is going to render our snapshots. Okay, because we're not going to have a browser. None of this is going to use a browser at all. And then it uses Jest to declare our tests. And what it's going to do is it's going to run this. It's going to use the render.create. Render.create is inside of our library that we just loaded, right? This kind of mocking the browser, right? It's removing the browser out of the equation, right? So it says, okay, well, take the the component that you want to render, in this case would be MyLink, right? Instantiate it and pass it some attributes, some properties, page and whatnot, and that's it. So it's rendering this. It's going to generate this. Create here is going to generate a snapshot. It's going to take the it's going to take this, because notice that this is what it returns. This is what it returns. So it's going to take a snapshot. It's going to evaluate the JavaScript. It's going to take the state. It's going to replace this with normal. It's going to replace this with Facebook, right? It's going to replace this on mouse enter as a function call, and on mouse leave is going to replace it with a function call. Okay, so it's going to take a snapshot of what the DOM would have looked like if you would have ran this on a browser. And it's going to save it into a file. It's going to save it into a file. Right? After that, notice that once we have the components, we can then use the components. We can then use the components to convert it, right? We can convert it into a JSON representation, right? That is going to. We can then use it as an input into our various expect functions. Right? So, for instance, we want to run the Jest and say, okay, take that DOM representation. Right? You want to expect that DOM representation matches the snapshot. Right? So render it. Doesn't match the snapshot. If it doesn't, right, which I just generated earlier, right, this would fail, right, and tell me no, it renders some other way, right? Instead of an anchor, somehow you change it to a button, right? And so it's supposed to be an anchor, not a button, right? If you make any changes like that. Later on here, we can take that same tree object, right, and we can invoke or simulate various events. We can simulate click. We can simulate change. We can simulate a keystroke. We can simulate a mouse movement. We can simulate on mouse enter, and we can simulate that event. And who's going to handle that? The JavaScript. The Java is going to handle that. It's going to run the tests. It's going to run the rendering engine on React, and it's going to have a new class for that anchor, right? And we're going to convert it back. We're gonna say, okay, well, get the new representation after having run this event, and create a snapshot. It's going to create a snapshot. It's going to compare it. It's going to compare and say, does it match what the snapshot would have been, right, with the correct class? If it doesn't match, then again, this would fail. Now here we're gonna simulate a mouse leave. Again, we generate the snapshot. We compare it with the snapshot that we're expecting, and if any changes when we rerun this test, it would rerun all this and validate that it's compared against the last snapshot. Right, so the last file that was ever generated, that is now considered to be the base, the expected value of how your page should be rendering. Okay. Typically, these snapshots are also included as part of your source, right? They're now part of your source code, right? And whenever we run the test later on, new modifications to the source code are validated against that one snapshot. If indeed you are making a legitimate change, right? That indeed you want to change the anchor to be a button, for instance, right? And it complains and saying, hey, this was supposed to be an anchor and now somehow it's a button. We can update the snapshot. We can say, yeah, I know this is a legitimate change, right? And this is not a bug, and you can re-update the snapshot. You can say, take this as the new snapshot, right? So that going forward, right, you want to make sure that it stays as a button, so that you don't inadvertently change it to something else. Make sense? So you can re-update the snapshot going forward if it's a legitimate change. So looking at the file that gets created, the files are created under the source directory, right? Under a new directory that our React tool generates, that it's called __snapshots. It's __. and to have the name based on the test that generated the snapshot. Right? In this case, it was MyLink.test.js, but it adds the .snap at the end of the file. And if you open it up, this is a file that can be it's pre-printed for human consumption. You can open it up. You can actually look at it and see what are the different states that your application can be in. Right. The initial state is that initially the state of the anchor was the class name was normal, right? That was the original state. It's Facebook, the 2 functions, and click me. So that's the first snapshot. If you keep going down, you'll see other snapshots. Again, capturing every single state that your component can be in as it interacts with various hovers. So, for instance, we hovered over this, right? And notice that the class name is now hovered. Okay? And when we leave the hyperlink, it goes back to just normal again. Right? So whenever you make any changes, it's compared against this file. Right? It compares against this file, checking to see if something went wrong in your DOM. It's no longer what you would expect. Make sense? Right? Again, this is one. There's many different ways of doing this, right? But this is one particular way of implementing the concept of isolating your code from the framework. In this case, isolating it from the browser, right? When you no longer actually need the browser. The browser is just it's an artifact for human consumption, right? That you render all this content, all these pointy brackets and ASCII code, and it gets rendered for our self-serving needs. Yes. But it's just data, right? It's just data that we can programmatically check. Make sense? All right, snapshot testing.